All right, so let's take a look. All right, if you look at the first, so after your first iteration, you should have 2.25, 1.25, 1.125. Then we got to go find our second slope, which is going to be the difference between these divided by the product of them. Did you get 0.444 or 4 ninths? Hopefully. Okay. So then we write the tangent line there is y minus 1.125 is equal to 4 ninths times x minus 2 1/4. What are we going to substitute in again is 2.5, or remember this quantity here, or this quantity here becomes just point what? 2.5, right? So it's 1.125. You're just adding 1 ninth to it because it's 4 ninths times 1/4, and you end up with 1.236. Yes? Okay. Questions? Yeah. Did you get the first point correct?
Yeah, I got it.
You got it? Okay. So let's look at 2a. Hopefully, did we see it was an arc sine? Yeah, question? It doesn't matter. Either one is fine. Typically, I'm just looking for the y value. I know that the final x value is because you already plugged it in, right? Yeah. All right. So if we look at number 2a, all right, hopefully we recognize who's arc sine. Is there a 1 over a out in front for an arc sine? No. Okay, but now we got to go evaluate it. And when we substitute that in, we're going to get what? 5 arc sine of, well, when I do 3 root 3 over 6, what does that become? Just root what? 3 over 2 minus 5 arc sine of 1/2. Now, those of you that are unit circle adverse, how do I say it that way? You got to be able to find those angles. So where is the sine root 3 over 2? That's the big one. So where is that one at? Pi over 3, right? So that's 5 times pi over 3 minus 5. Where is the arc sine 1/2? Well, that's saying where is y 1/2? That's at pi over what? 6. Okay, what's pi over 3 minus pi over 6?
Negative pi over 3.
Pi over 6, right? This is 2 pi over 6 minus 1 pi over 6. So it's 5 times pi over what? 6, or 5 pi over 6. Did we get 5 pi over 6? Okay. If you're adverse to using your unit circle, remember, it's the gift that keeps on what? Giving away, that you keep giving away points. Okay? It's a gift that keeps giving away. All right. So if we look at number 1, what method do we have to use for 1? Part Y. What's our clue? It's what? Factorable. Okay. So if we do a over, and I think we're pretty good with this, a over x plus b over what then? 9 minus x. If we cross multiply, remember we're doing side work here, it becomes 18 is equal to a times 9 minus x plus b times what? X. Now, I want to ask you before we do anything, are a and b going to work out to be the same? Or same but opposite, possibly? What's your clue? We got a constant on the left, right? There's not an x there. So what are our key values when x is 9 or when x is what? 0. When x is 9, I get 18 is equal to 9b. So what's b equal to? B is, hello? B is 2. All right. When x is 0, what do we have left? 18 is equal to 9a, so a is also what? 2. Oh, does that happen? Yeah, that happens. All right. I hope I gave, yeah, I did give us enough room. So this is going to become what? The integral from 2 to 3 of 2 over x minus what? 2 over 9 minus x dx. All right. What is the first one? It's ln. So it's 2 ln of the absolute value of x. Okay. Oh, I wrote minus. That should be a plus. All right. But when we do that antiderivative of the second one, what is going to be in front? Not just a 2, but also a what?
Negative.
Why? Because the x is what? Negative. So it's minus 2 ln of the absolute value of 9 minus x. Okay, now we have to look at it from 2 to 3. But before I evaluate, what should I do with those two terms? Divide them, right? So I'm going to rewrite that as 2 ln of the absolute value of x over what? 9 minus x. And now we're going to go do that from 2 to 3. All right, when I plug in 2, what's our numerator? 3 over what? 6, right? Minus 2 ln of, what do we get on the bottom, is 2 over what? 7. All right, what should I make that first one? That's 1 what? Half. So we know it's going to be, it's really 1 half. All right, so I'm going to get 2 ln, but I'm going to end up dividing them. How about we just, well, if we divide them and I do 1 half over 2 sevenths, what does that become? 7 over what? 4? So it's 2 ln of 7 over 4. All right. I know that's a lot. With the partial fractions and evaluate. All right. So I want you to go do 2b and 3. Okay. Is 2b an arc sine? Yes.
For the standard Euler's method where x equals 2.25,
Mm-hmm.
why is this slope the same?
That's the slope. Remember, that was our increment of 0.25, right?
Yeah.
Here, our slope was 4/9. So that was our slope. That was our increment, right? When I plugged in 2.5 minus that, that's 0.25, or it's 1 what? 4. That's the slope there. That's the slope there. It was, remember, that piece, because of Euler's method, we're going over the same amount. That's going to be that one. Would it have been easier for you if I wrote it as 0.25?
I don't know.
Okay. Does that make sense then?
Yeah.
Okay. All right. So I want you to go do, so why, by the way, why is this not an arc sine? Because you have a what on top? 2x, right? So you have to do a regular what? Substitution. Okay. I want you to go do 2b and 3.